today we're going to talk about the DoseView 3D water phantom. We say take the hassle out of annual QA, optimize with ease, and that's kind of a key takeaway of our system. It's a very easy system to use, very straightforward, uncomplicated software, and gets you the scans you need and the processing and everything you need to get up and running with your scan data. So real quick, some of the objectives, of a water phantom, obviously your acceptance testing. You check those treatment systems versus your manufacturer stated specs. Commissioning of the Linux, so you're checking all your different energies, all your different field sizes, your wedges, et cetera, all your different scenarios for scanning. And you want good beam data to be able to import into your treatment planning system. So that's something we take into account as well and do very well. Any host of different treatment planning systems can be imported to, and I'll touch on those in a bit. And then, of course, you have your routine QA, your annual QA, your monthly QA, following different protocols such as TG142, TG51, TRS 398. So those are there as well. And then you also have periodic tests of beam quality as it's needed. If you're seeing that maybe your daily measurements or your monthly measurements aren't quite up to snuff and aren't as the quality that you want, you may pull out your water phantom to check those. And of course, after say a major repair or upgrade on your Linux as well. So that's kind of obviously what your objectives are for water phantom QA. And kind of some of the specifications. What makes a good water phantom? Obviously, you want highly accurate and very repeatable positions for your system and your detector to go through the water. So you have that accuracy. You want high quality raw measurements. Raw measurements that alleviate any need for post-scan processing. And really, the more you massage the data and change the data, the more you're not getting true results that you're looking for. So you want those quality raw measurements in your scans. Something, best case scenario, you're not using this on a very frequent basis. So you definitely want something that's reliable, that's going to give you operation year after year, when you pull it out of storage and do your scans. So that's something that, that reliability is something we're very proud of with our system, because it is a very robust system and kind of very reliable as time goes on. You want easy setup, since again, like I mentioned, you may only be using it best case scenario on an annual basis. So you want something that's easy to set up and use. You don't have to kind of, if you will, relearn the software or forget how to set things up. Some of the more automated systems, things like that. With ours, it's a very straightforward setup and pulling it out, getting that software kind of refreshed in your mind is very easy as well. And you want that flexibility and compatibility. Obviously, you can use a whole different detectors, be it the diodes or be it the ion chambers, or we also have a dedicated unique scintillation detector, our W2 for scanning. So it gives you the ability to use a whole different host of detectors, different protocols, whether it's TRS or whether it's the AAPM task group protocols, the TG142, for example, things like that. And then also the different treatment planning system formats. We do a whole number of different ones, which again, like I said, I'll touch on in a little bit, but various Eclipse and Pinnacle and Array Station, Monaco. So they're all included in the system. There's no additional fees for that either, which is a very, very key point. Our system includes basically a turnkey system that gives you everything that you need to start scanning. So let's move on to the system itself. Some of the big things, we always say better hardware, better data, because we really took pains in the development of our water phantom to really kind of give it. In some respects, it's over-engineered because it really gives you a nice platform to do your scans on. We use a heavy gauge extruded aluminum, which maximizes the rigidity. It simplifies the setup and it maintains that reproducibility year after year. And the takeaway there is that, it's really that rigidity that gives you really, really strong accuracy, because the framework is very solid. There's no flexing. There's no cantilevering in the system. We have redundant in this water phantom that gives you much more accurate movement of the system, because you're moving two motors on opposite sides to be able to really maintain that reproducibility. And that positional accuracy and repeatability is 0.1 millimeter per axis, so you know that the accuracy is there. It allows for very, very quick and precise 3-point leveling. One thing is we do have a manual leveling system, but we've got a very unique alignment setup to help you through that, and I'll touch on that as well. It's just as quite honestly, just as quick and easy, and actually probably a little more adjustable than some of the auto leveling systems out there, and I'll touch on that in a bit as well. And then, for that accuracy, even before the systems go out the door, every system is tested on an industrial coordinate measurement unit to verify the accuracy and performance of the system. And that's a 39-point measurement throughout the system and throughout the volume of the position of the scanner. So it's a very, very accurate test, and we make sure that we verify those accuracies before we ship the unit out. A few other things on the hardware side, designed for ease of use and also to maintain that structural integrity. The tank and the frame are secured together, so that again, ensuring that long-term integrity and accuracy throughout the life of the Phantom. And that's something that's fairly unique to ours. We don't have a floating frame, so to speak, that just sits on top of the system. It actually is integrated into the water Phantom tank itself. We have this is kind of a small point, but it's very it gives you it's kind of unique, but very beneficial. We've got a suction drain that really, when you drain the tank, it works to suck the water out of the tank and minimize any water in the tank after draining. So it makes for a much easier moving of the system. But also the big thing is that you don't have residual water sitting at the base of the tank that the robot, the scanning arms will sit in and cause mineralization or things like that as the water does evaporate. So it takes that water out of the tank automatically at the base, and doesn't leave any residual water sitting at the bottom of the tank. And then we also offer the fully integrated lift and reservoir cart with a precision positioning platform, which I'll touch on in a second. But it makes for good, very good ease of use and convenience for getting the system up. You roll it in. There's an integrated pump within the system. Fill the tank, drain the tank, all in the same cart, and it's a very quick and easy setup for that as well. Saving much valuable, saving that valuable time that I know as a physicist wearing many hats these days has a lot of duties, and scanning can be time consuming, but we want to try and make it as quick and painless as possible. So a little bit about that positioning platform. So it has a rotational platform, as you can see there. It's aluminum plate that sits on a nylon base. So it rotates, and it gives you the ability to rotate that tank and lock that tank in at those 45 and 90 degrees. So if you're doing diagonals, you can rotate at 45 degrees and lock it into place with the accuracy that is necessary for doing those diagonal scans. So that's a nice feature there. Then you'll see on the edges, we've got the 3 black levers, one kind of hidden by the rotated platform. But those are fine adjustment levers. They give you the ability to adjust in the in-plane and cross-plane at very fine increments. So you get the course adjustment of the position of the light field and the center axis line from your laser or from your light field illuminator. It gives you to then fine adjust and fine tune those positions both in X, Y, and also rotate. So it's really nice there for the Phantom in place. The Phantom itself, about 4 years ago, I guess, maybe around 4 years ago, we actually updated to our Generation 2 hardware to make it compatible with the Halcyon unit, and gave it a lower profile in the Halcyon 4, impacted the design and even improved upon the original rigidity of the system we had in the first generation. So makes it compatible to those Ethos and Halcyon systems. And the nice features too on that is the ability. There's a Halcyon fill line, because obviously sitting on the couch with the water Phantom, there is a weight limitation. So we have a built-in line for full tank for use for conventional C-arm on our lift cart, or a Halcyon fill line to still maintain the couch weight limits for the Halcyon system before you move it into the bore. Some other uses of convenience we have, wireless. So you see our image of our pendant here. It's intuitive wireless pendant, has a full control of the robot system and a few other things built into it, including a feed out of your Z position. Thanks for that simple system can be about having the wireless pendant being tethered by cable. The water Phantom control system is you can walk around the Phantom to check your runouts, check your leveling, things like that, very easily, very quickly, and conveniently. It's just a nice feature to not have the pendant cabled to the system. Onboard display always shows that pro position where you're at. You can set your origins, you can set soft limits. For the Phantom, there are hard limits built into the firmware of the Phantom, but this allows you to also set your soft limits of your in-plane, cross-plane, and depth measurements to avoid, if you're using a larger chamber, things like that, to avoid running it into the wall of the Phantom, things like that. So it helps avoid any issues. 3 touch button probe speeds. There's 0.1 millimeter step, and then there's a fast and a slow. The fast, gives you, the ability to kind of set things up quickly, but then you want to fine tune it. You can use that slow speed or that 0.1 millimeter step mode as well. It really gives you some, good options for setting up the water Phantom. And then we also, a nice convenient feature is we have a bias switch right on the pendant. So, a lot of times you're in and out of the bunker, and you might go to the console. Get everything set, turn on the bias, and then you realize, I have to adjust my reference probe or something like that. You go into the bunker, and then you realize that you forgot to turn the bias off on the chambers. You don't want to do any adjustment on the chambers with the bias on. So instead of having to walk back out of the room to the console and the software port point, you can actually turn that bias on and off at the pendant, which is just, again, a nice little time saver and convenience feature. And additionally to the wireless pendant, we also include the ability to do your measurements either wired or wirelessly connected to the PC. We include a radio system that allows you to communicate. Basically, it becomes an air bridge between the water Phantom and the PC, using a radio built-in transceiver receiver in the unit, but then also a second receiver that you can place at the wall of the bunker to receive and transmit those signals. So it just offers that versatility and convenience. You don't have cables to be tripping over for the connection to the PC. So moving on, something that Standard Imaging is very strong with is our electrometers. We have a long history of electrometers from our Premier 3000, our CDX 2000, and our Max 4000 to our Super Max. So those are all the standalone electrometers that we've offered in the past. We also just introduced a new Max Elite electrometer. So we've kind of built upon that history and and knowledge into our dose view electrometer. It's a charge digitizing electrometer, giving you a high-speed acquisition, which is imperative for scanning. It's got a very fine 10 femtocoulomb resolution, so it's a very fine resolution for your measurements. Dual polarity biases, so you can do positive or negative bias as needed. And then we also have the independent bias voltages. So if you're using, say, a diode for your field chamber, and you're using a ion chamber for your reference chamber, you can turn those biases on independently, because obviously you don't want to put bias onto a diode, because you damage not only the diode but the electrometer as well. So the nice thing about it too is that if you're using a diode, the software has built-in protection where if you have a diode listed and in the library for chambers, and you go to use that, you can't even turn on the bias. So that's just an added protection system within the software to help protect that diode and not avoid damage to those. I kind of mentioned we don't have auto leveling, but we do have a very straightforward leveling system with very fine micro adjustment, and we've got a detector alignment jig that allows you to place it on the carriage where the chamber would sit. And then you can kind of easily do your runouts, easily do your tracking, get your level of the water. And then as you move out left or right, you can do a fine, quick adjustment on the phantom itself, on the frame, and adjust to the water level. And quite honestly, while it's not an automated leveling system, it's just as quick, because obviously if you're doing an auto level and for some reason it does not quite do the leveling correctly, or if it stops mid session of leveling, you need to kind of start that all over. Where ours, you through your adjustment and through your leveling system, you can do a quick adjustment, and quite honestly, you can be scanning in about 10 to 15 minutes after the tank is filled and settled. So it's really not any slower than your auto leveling systems, and can actually end up being a little more accurate. And in doing that, we also have an alignment jig for the chamber. So you see the image here of the alignment jig has the same setup and the same screw mount as the chamber holder. So you set this up to your point of measurement, and then all you need to do is take this piece and replace it to that. And it puts all those detectors at the same reference depth and allows the swapping of any ion chambers or diodes without having to reset the tank origin or the isocenter. So that helps speed up things and help things, for that convenience. If you want to go from full large fields, if you want to change to a small, stereotactic diode, or a small field chamber like our A26 small field ion chamber, you can easily do that without having to reset origins and reset the isocenters on the system, because we use that and maintain that positional correctness with our detector holders. And that being said, we have a whole host of different detector holders that are included with the system at no extra charge. So we've got a universal one that'll hold a farmer chamber or some of your larger chambers. We've got some micro chamber specific holders. We've got one specifically for our A28, which is our scanning, our 0.125 ion chamber scanning chamber. You can see there's also chamber holders for parallel plate chambers. So if you're using a Marcus chamber or a Roos chamber or any of our parallel plate chambers as well, those are all included in the package. Like I said, it's a turnkey package, so there's no hidden fees or hidden costs beyond what you initially invest in the system. Another nice time-saving feature to get you scanning in less time is our locate beam center function. And basically, it helps you locate the beam center in the X and Y location or direction, and define that origin. You can do that at multiple depths to check your leveling. We are working on a new version of software which will automatically be able to do. You choose 2 depths, and it will locate that center at those 2 depths, and then give you the ability to kind of adjust. We call it skew correction, to adjust for that that leveling skew if there is any. And quite honestly, the leveling is so accurate that it's pretty rare that you need to make any skew adjustments for the system, but it is there should you need it. So basically, the chamber moves out to the 50% lines in the X and Y direction, localizes on those, and then gives you any necessary shift. So it gives you that ability to fine tune your central setup of the beam. Just a nice, another, we build everything around convenience, honestly, for the DOSU Phantom. Additionally, one other point real quick, our software is set up to be able to do both 3D and 1D. You can use our 3D Water Phantom, but you can also utilize the 1D Water Phantom and either our Supermax or Max 4000 line of electrometers to do your depth measurements and your single point measurements. So it just kind of makes things, kind of a similar ease of use with the software as we do for our 3D for the 1D. And I'll kind of touch on that a little bit as well. I mentioned our ion chambers. Another thing along with electrometers, we've got a long storied history with ion chambers. And the ion chambers that are included with the DOSU are no different. That's, as I mentioned, our 828, the X-ray 828 scanning chambers, which is kind of a typical 0.125 cc scanning volume. It's actually it's a spherical scanning volume. So whether you're scanning in cross-plane or in-plane, you're going to get very similar, very kind of equivalent results. And nice thing about our chambers, and this is our whole chamber line. We utilize a homogeneous Schonka plastic collector guard and shell. So all 3 main components of the ion chambers are Schonka conductive plastic. So there's no high Z materials in the chamber, so there's no beam perturbation, so to speak. It's a very, very robust system, and they're very, very strong too. Instead of using a graphite shell, it's that Schonka plastic, which is very, very robust. And because of that, we can offer a 5-year ion chamber warranty on all our ion chambers. And then we also have a pair of different diodes. We've got a horizontal and a vertical orientation diode for stereotactic. And as I mentioned, we also have our scintillation detectors. It's the first commercially available scintillators for scanning, our W2. It's a 1 by 1 millimeter scintillator, and very good it's water equivalent, so very good for doing small field measurements and stereotactic field measurements. So that's kind of an overview of all the hardware. Jumping into the software now real quick. We've got our DOSU software, and as I mentioned, you can see there's an entry point for either the DOSU 3D or the DOSU 1D. It's very intuitive scan menus, gives you the ability to do a quick scan setup, quick measurement, and quick analysis. And I'm going to do a quick overview of the software, but I'd like to invite anybody who wants to get a deeper dive and a more in-depth look at the software. Please feel free to reach out to us. I've got a couple of email addresses at the end that you can contact, or look on our website for contact as well. To maybe take a deeper dive, because our software really does shine in a lot of ways, because it's a very, very clean interface, very easy to use. It's easy left to right, top to bottom navigation. So something you're used to. There's no what we call hidden features. The hidden features are things that you might have to hunt around for in other system software. Everything is right at your fingertips with ours. There's no host of, I've got to go through 10 folders or 10 tabs to find what I'm looking for. Everything is right there, and that makes things so much quicker and so much more uncomplicated for daily use and for scanning use when you do pull the scanner out. And then, like I mentioned, it's fully integrated for your 3D and your DOSU 1D scanning. So that being said, I'm going to take a quick jump into the software. I'm going to, again, like I mentioned, it's going to be a quick kind of overview software, and I'd like to invite anybody again to have a deeper dive to set up a personalized demo with your rep, and they can kind of get in touch with me, and we'll get that scheduled, and I'll run through the software more in depth. But basically, for this situation, I'm going to jump into the DoseView 3D software, and I have basically it comes down to 3 tabs. You've got your setup tab, your measure tab, and your analyze tab. And quite honestly, your setup tab, really, once you set it up for your clinic and your LINAC, you don't necessarily even have to go back to that one. You set up your scan queues here, so you have your scan queue set for future use, things like that. So really, like I said, once you're in here and you set this up, you don't even really have to go back. But you can enter in your clinic, you can enter in your different machines, and then in each machine you can enter in your different your specific energies. Like for here example, I've got 10 and 6 MV, and I've got 10 and 6 triple F. Obviously you're going to have some electron energies as well, but it's very easy, quick setup. You can add everything in your add dialog here. You can enter in your LINAC name, who the manufacturer is, what model is, etc. And then you can add your different energies here. Again, like I said, either MV, electron, or your triple F energies. So it's a very quick and easy setup as well. And once that's done, you can also enter in all your different detectors. You can put in the type of detectors, whether they're a cylindrical detector, whether it's a diode, whether it's a parallel plate, etc. Very easy to add those and detect those when you're doing your scanning. Scan queues, I'm going to jump over just real. Whoops, sorry about that. Just real quick, and go to the preferences. And this is just kind of where you set up. I know worldwide, different regions have different CSV delimiters. Some use a comma, some use a semicolon, etc. Same with decimal separators. Some use a comma, some use a period. This date format. So it's pretty straightforward there as well. What the preferences are. Go into the scan queues, and this is kind of really a nice system too. I can also say our scan queue setup is probably the easiest and most straightforward of all the systems on the market. It kind of walks you right through as a little bit of a wizard, if you will, to help you set things up. And you'll see basically as you set things up here. I'm just going to do a quick setup for a demo. And as you see here, as you set things up, these get marked complete, but you can choose by medium, whether I'm scanning water or air, what my modality is, what my field definers are. I'm going to do some MLCs on this one. And if I'm doing electrons, obviously you can choose a cutout. You can choose a wedge if you're doing dynamic or hard wedges. SRS cone functionality as well, so you can utilize that. So then your field sizes give you the ability to use diameters versus a rectangular X and Y sizes, things like that. So it gives you a quick setup there. You can quickly choose your energies. I'm just going to do 6 MV for this one. My field size, I'm only going to do maybe a 10 by 10 for this one, and maybe a 20 by 20. And then my scan types. I want to do in-plane, cross-plane. I'm going to do some depth scans. I have the ability to do diagonal scans for very large fields, and I also have the ability to do half scans. So I can do a positive half, a negative half in the cross-plane and in-plane directions. And then the software later on in the analysis page will give you the ability to kind of stitch those together for a full scan of those 2 half scans. So my depth, I'm going to just do one maybe 1.5, and then maybe one at 10. And then my CAX offsets too. I just want to do it in the central axis, but if I want to do some offsets, I can certainly add those accordingly in both the positive and the negative direction. So easy enough to add different positions. But in this case, as I mentioned, I'm just going to do center axis for the demo. And then my scan mode, and you'll see they're all marked complete. So I can go ahead and start scanning now. But the scan mode, there's a couple different things that allows me to do. I can choose my mode. I can do either step mode or continuous. So step mode, I choose my step sizes. In this case, my resolution of 2 millimeters, or my continuous, and now it switches to millimeters per second. And that gives me the ability to adjust that as well. My zones are either a zone where the resolution is the same all the way across, or a multiple zone, which I can change the sizes. But if I want to do a higher resolution in the high gradient region, the penumbra here, I can change that accordingly as well. So now I'm doing 2 in the tail and 2 millimeters in the flat region, but I am doing 1 millimeter higher resolution in the high gradient region. And I can choose my overscan distances. I can choose the size of my scan zones as well. And I can also do that for my depth as well. So if I want to do my depth scans, again, step or continuous for the 3D side. I can force a point at Dmax. So if I have a path will not necessarily measure a point at Dmax, I can force the pathway to make a measurement at Dmax and then continue on its original path. Choosing those zones, I can do single or multiple. If I want to have a higher resolution in the Dmax region, I can do that. I can choose my direction up or down, etc. So you have a lot of different ease of use functionalities here. So that's all set. So now my total number of scans for this scan set is 10, and then I can go ahead and save that. And that's really all I need to do in the setup. So once you set that up originally, you can set up all your scan protocols at once. There's copying and edit functions for different scans, which makes it easy to kind of duplicate things. I can import scan sets from other DoseView instances. So if I've got a partner clinic that has a DoseView, I can bring those scan queues right in and use them as well, without having to kind of reinvent the wheel, if you will. And then second, now you move into the measure. This is kind of where you set up your hardware. So I choose my machine. In this case, I want to use my Versa Agility per se. I can choose my dose rates, and this is where I set my dose rates here. I can set my scan step settling times, things like that. Nice feature too is that, again, as I mentioned, you might not use this the whole, but once a year. So you have the ability to choose this mode here, Demo 3D, and that just gives you kind of a playground to kind of reacquaint yourself with the software, if you will. So instead of having to be connected to the Phantom and taking up Linux time or convenience, it gives you the ability to connect and initialize, choose your detectors. I've got my A28s here, which are my scanning chambers. I have the ability to not use a reference chamber if I want. Typically now you would be using a reference chamber. Select my electrometer, choose my bias, and I can apply it to the field or the reference. So I'll do maybe 300 for the field and the reference. I can zero my electrometer from here. I can set my positions. This is where I do that locate beam center that I talked about. I can set my origin here. I can move it around. I can go to specific positions. I can go back to origin, things like that. This is showing the future. This is a beta version, so it's still showing the skew correction that I mentioned as well. So that's got the functionality there. And then also my Phantom orientation. And this is basically just how the Phantom sits under the gantry. So this here is this notes our motion control box and just how that sits under the gantry. So if I come in from the side, so to speak, I can mark it there. And that just orients it to what is X, what is Y. So, and similarly, as I mentioned with the scan queue setup, now that these are all marked blue, I am ready to start scanning. So I go to my queue, I can load that queue very easily. It's on the bottom here, my Demo 3D that I just put together. This is just telling me make sure that my dose rates are correct. I can zero my electrometer, which I've already done. I can do a quick, I want to do a quick normalization to Dmax. So I move to Dmax, I normalize, I close that, and then I'm ready to scan. And now I'm scanning. So my beam is on and I'm actually doing my scanning. It shows here in green what your active scan is and your percent completion. You can see this is being in demo mode is actually kind of doing a fake scan here, but it's kind of doing a depth measurement first, and then you'll go to my cross plane and my in plane, and then it'll tell me, it'll indicate with a ding and a dialog box saying I need to change something, either the energy or if I'm doing multiple energies or if I'm doing multiple depths, things like that, or field sizes, I should say. It just notifies you that you need to change something. So it's pretty convenient there as well. But really, that's all it is. And as it's scanning, the nice thing too is I can jump right into analyze, and I can start analyzing any of my my set scans. So I can go ahead and pick a few. I'm gonna go down here. I got a few that I use for demo purposes. I can get to them. I go. And 3. Let's see. And I'll tell you why I'm doing some of these in a bit. But I can kind of I can filter down with anything. So I just want to see my data from a specific clinic, from a specific machine, my tags, things like that. So my energies, I only want to see my maybe my 10 MV, my 10 MVs, and I only want to see maybe my depths for my cross planes, things like that. So I chose those scans. You can see they're highlighted in blue for the ones I chose. I'll bring those in, and they show those scans. We'll bring those in. They'll show what the scan IDs are here. The metrics, very quick and easy viewable metrics are here. So again, it all comes down to that convenience and uncomplicated views of my results and what my metrics are, my edges of my field, the center of the field, my penumbra widths, my central axis positions, my max percentages, my minimum percentage, things like that. So everything is within the purview of one page here. You don't have to go digging for your results and things like that. It'll also, any filters I have assigned. So right now I've got to normalize at center. I've got to normalize at value, which I did originally. So that's giving me my normalization values. I've got a host of filters here. I can do a couple smoothing filters. I've got a Gaussian and a boxcar filter for smoothing. I've got a point edit. So for some reason I get like one wonky point. Maybe there was a glitch in the delivery, or a cable got irradiated and it gave you a weird point or something like that. You can edit that point. I've got the ability to normalize to a specific value. I can normalize at center. I can center the scans. I can do an average symmetric of the scans. I can flip, mirror. I can mirror either positive, negative, or negative, positive. I can flip, and I can also do a full shift. And that's the same with my depth measurements too. But I want to add a depth scan that I wanted to show. Maybe go back to my 10 MB and my depths, and I'll just grab one, maybe grab a couple to bring in. Easy enough to bring those in as well. And there's my depth measurements and my scans there, my metrics for those, showing you my Dmax, my percentages at the various depths. And I have different filters there as well. So I have my smoothing filters. I've got my point edit. I've got my normalization at depth and a point. I've got my ability to do a shift. And then I also have my ability to convert to dose. So one of the things when you add in your chambers, you put in your chamber diameter, and then it'll automatically take that chamber diameter, give you the effective point of measurement, and assist in automatically converting that to dose. So all that functionality is built into the system. And as you can see above here, I've got a number of different things as well. I've got the ability to add and clear scans. I can save them as a scan set. Here's where I mentioned you can merge those half scans. I can remove any filters that I have, either last filter, or I can clear all the filters and process anything if I wanted to. Again, you can look at your scan sets. I can export, and I can export to pretty much any number of different things. As I mentioned, have Variant Eclipse, Monaco. I've got Pinnacle. I've got Rayplan from Research, the CyberKnife Precision. I've got Electa Aqua, which is their QA database system. And then I can also export to other dose view systems. I can export into CSV. I can actually export as a PDD with my depth measurements, my depth curves. can be put into a PDD table. And then from that PDD table, you can do a calculated TPR as well. So that's all your different export functionalities. And I can also import. So from other DOSView systems, I can import data and import scans. Nice thing too, we also have a tool that will allow you to import legacy data from an IBA or PDW scanner. So if you have older IBA or PDW systems that you're replacing and want to bring those scans in, you can do that. And then you also have the ability to report. So we have a CSV report, and we also have the ability to do isodose PDF curve reports as well. And then, the last thing I just wanted to show real quick was reference scans. You can choose a set of reference scans, and those kind of become, so to speak, your baseline. And then, then you can do a comparison of those reference scans, and that will give you not only a gamma analysis comparative from your reference scan to your subsequent scan, but also will give you a comparison, as you see here with our metrics, the different positions and the different comparatives to that reference scan. So in this case, 250, 251, 231, and 405 are my subsequent scans, and 248 is showing as my reference scans. And those are just your comparisons, so you can compare those to the reference baseline. So, but that's kind of a quick overview of the DOSView software. Like I said, it's very uncomplicated, very easy to see how to kind of move through your scans and move through setup of your scans and your scan queues and things like that. You can see it's still processing through here. Even though I went into the analyze, I was looking at, so it has the variability and the convenience of being able to scan in the background, but still go and do some analysis on your completed scans. So I'm going to jump real quick back to the PowerPoint and go forward from there. So again, the DOSView software, it's a quick queue setup for convenience for your depth scans and your profiles for all energies and modalities, conversion of those depth scans to DOS, and the export to the PDD tables for converting, then calculating into a TPR table, and then again export to numerous treatment planning systems. And as I mentioned, all those treatment planning systems are included. They're not additional charges. I know some of our competition charges you per treatment planning system. So if you're one of the facilities, or you have facilities in your group that uses different treatment planning systems, there won't be additional costs for that. It's all part of the package. And again, the water phantom, the lift cart, the ion chambers, all the chamber holders, et cetera, all included as a turnkey system. So, the DOSView, going back to the hardware, we've got very intuitive and versatile detector alignment system, as I mentioned. Gives you a really fast setup and leveling. It's very quick, even though it is not necessarily, so to speak, auto leveling. It's just as fast, and we've kind of had a point by point comparison where we had competitive. This was done down at MTMI, I think, in Houston, if I remember correctly, the location, where we had ours up against the other competitive scanners, and we set up just as quickly as those using an auto leveling system. The structure is designed for unparalleled repeatability and accuracy. That's kind of unparalleled. Again, we use a very, very structured framework system on our Phantom, so there's no flexing or cantilevering of the system. Everything is precise within 0.1 millimeter axis. We have the wireless functionality built in, both for the pendant itself, but then also the availability of either a wired or wireless system for convenience. Fast acquisition electrometers with independent biases. And as I mentioned, again, it's a turnkey system. One cost to you, has everything you need out of the box to start scanning. There's no hidden fees or additional costs. The only caveat to that would be your annual maintenance, which will give you any and all updates of the software, both updates and upgrades of the software under maintenance. So That also includes, we have both software only and then software and hardware too. So that includes any replacement components of the hardware. That's one more nice thing about the hardware too that I didn't mention, is that it's a modular system. So everything is field replaceable. The motors, the cables, the track system, everything can be done by the physicist, or our service person right at your facility. There would be no need to send the system back for repairs. We can do that right at your location. We also have full instructions to, if for some reason, to replace a motor. It's 4 screws, automatically recalibrates itself to its partner motor, and you're good to go. So everything is kind of built again for convenience and speed to make things very quick and easy. So, and again, last, the DOSU software, quick summary, easy navigation, left to right, top to bottom, fast queue setup with very quick and easy copy and editing functions for convenience. Again, no hidden features. Everything is at your fingertips. You don't have to go digging for results or for different test, features, things like that. Full exports of numerous treatment planning systems included with the system at no additional cost. The import functionality for legacy scan data. Like I said, if you have an older PTW or IBA system that has scan data, you can import that with the import tool. And then our straightforward post-scan processing metrics and scan comparisons all at your fingertips as well. So, again, like I mentioned, everything is made for convenience and ease of use for the physicists, because we know that, especially with your commissioning, it's a long, arduous process, and we hope to try to make that as quick and easy as possible for you. So, and like I said, in version 2, we've added the scan comparison, the TPS, TPR table exports to CyberKnife Precision, the isotope curve generation, and we kind of tightened up our sub-millimeter depth resolutions as well for your depth scans. And we're working on version 3.3, which will have that skew correction as well. That should be available probably in the next couple of months. Another nice thing, and very, very positive thing to hang our hat on too is our support. We have seamless support. It's quick as a phone call, quick as a email, quick as a online chat. We've got a lot of different avenues to contact support, and they're always available for your assistance. Something we're very proud of, and very we know that when you need support, it's something that usually is brought on by an emergency. That's why we're always there to assist. So finally, as I mentioned, as a quick overview of the software and the hardware, if you want a more in-depth look at it, please feel free to reach out either to sales@standardimaging.com or hpeterson@standardimaging.com. That goes directly to me. We can set something up at your convenience to show you the full run of the software. But other than that, I'm going to take a look and see if there are any questions.
Thank you. I can read off some that we have had submitted, if that works for you.
Okay.
Perfect. Yeah, thanks, Hugh, for that great presentation, all that great information. If you have questions, like you said, just submit them in the chat or the Q&A tab, and we'll get to them. So first up, someone's wondering, is there any special extra test that is needed in machines such as Halcyon for our annual QA?
Not really that I'm aware of. You're still doing mostly a static beam in the Halcyon. So your profiles and your depth measurements, but I'm not aware of anything specific outside of just what you're doing with your conventional scanning.
Awesome, thank you. And then another one that came through here, since you don't have auto leveling, how do you compare with other systems as far as setup?
Well, like I mentioned, we've got that. We've got a very unique alignment jig that allows you to set that at water surface, and then very easily you do a run out, say at 5 or 10 or 15 centimeters, positive and negative. Check your leveling there. Do a quick adjustment with the leveling on the Phantom. And quite honestly, like I said, we did a side-by-side comparison down at MTMI. Again, I want to say Houston, somewhere in Texas. But comparing some of the auto leveling systems and the setup of the other systems and competitive systems to ours, and they all fared about the same time-wise, whether it was auto leveling or not.
Awesome, thank you. And then the last one that I'm seeing here, it says you mentioned the rotational platform. Can you elaborate more on that?
Yeah, so the nice thing about it, again, it's an aluminum platform that the water tank itself sits on. It locks into place on that, and then you can actually rotate the tank to your 45. So if you're doing a 45-degree diagonal, it will actually there's detents in the platform that kind of lock it into place. So you kind of rotate it, and you can feel it kind of click into place with that 45. And makes your diagonal scans very, very convenient. And then, like I said, also you have the three fine adjustment levers, the X, Y, and rotational levers. Once you get it under coarsely positioned under the center crosshair, then you can do those fine adjustments and really kind of hone in on the center of the position of the beam. So very quickly, very easily, and pretty conveniently, yeah.
Awesome. Thanks. That's all I'm seeing for right now. So.
Okay. And again, last point to make again is please feel free to get in touch with us if you want a little more information, get a deeper dive into the software or any other questions on the hardware that might come up. Otherwise, I thank you all very much for your time. And I look forward to hearing, hopefully, from some of you, or if not all of you, for more information. Thanks very much.